This is lesson 2.6, video supplemental video examples. We'll be using these definitions and postulates and theorems to complete our proofs and mostly to start our proofs for these first several that we do. In class, we will be using them with multiple terms from this. So this flipper is a very helpful tool. If you haven't already done this, you want to get into Skyward and write these down. It's a foldable so that you can look and say, okay, if I'm given this information that A and B are supplementary, what am I going to write for my next line? Well, my next line in my proof might be measure of angle A plus measure of angle B equals 180 degrees by definition of supplementary. This definition also works in reverse. So if you come down here, we see angle A and B are added to 180 degrees. We can make a conclusion about angle A and B, angles A and B. We can say that they are supplementary, again, by the definition of supplementary. So definitions actually work both ways. You can be either given this information or this information and conclude the other one using the definition. Postulates and theorems are a little different. They tend to happen in a specific order. We have not covered the triangle sum theorem yet, but most of you know from your explorations in middle school that the angles in a triangle add to 180 degrees. That is the triangle sum theorem. We will be proving that in a later unit. And then we have something called the exterior angle theorem. You don't need to worry about that for proofs right now. Linear pairs you should know. They are supplementary by the linear pair theorem. And then because they're supplementary, they add to 180 by definition of supplementary. Should be able to identify vertical angles and say that they're congruent by the vertical angles theorem, something we'll be proving in this unit. Some of these other things, definition of midpoint, angle addition postulate, segment addition postulate, definition of bisector. Those are all important vocabulary terms. Now, when we get to the Unit 2 vocab, you'll see some of this is already in 2.6. To say something is congruent to itself is the reflexive property of congruence. I don't want you to do anything with the parallel lines for now, though. Don't even copy those down until we get to that lesson. So we're going to be using that flipper as we go through here. So the first thing I see is that angles A and B are congruent. And by definition, that means that they're equal in measure. So the first line of my proof will be that angle A and B are congruent. It'll be all of this given information right here. And sometimes they are separated. The given information is separated in the proof. But for now, I'm going to write that as my given. The definition of congruent tells me that measure of angle A is going to equal the measure of angle B because of the word congruent. And since it's because of the word, that word, if you look at your flipper, when you're told that things are congruent, you can say they're equal in measure by the definition of congruent. Now we are also given expressions for measure of angle A. So I'm going to plug those in. This is angle A right here, 35 degrees. This 3x minus 5 is angle B. And so all I've done is plug it in. So my justification is that I used substitution, which I do need to write out. And then number 4, line 4, I'm going to solve the equation. How do I solve the equation? I start by adding 5 to both sides. So by adding 5 to both sides, this becomes 40 equals 3x. So this is addition property of equality. And then my very last line, I'm going to divide by 3, giving me, well, it's not my very last line, 40 equals x. And that is division property of equality. But there is one more line because I wasn't supposed to prove that 40 equals x. I was supposed to prove that x equals 40 thirds. I can say that right now for my 6th line, x equals 40 thirds. All I'm doing is switching the order of what's on each side of the equal sign. So if you've done lesson 2.6, you know that this is the symmetric property of equality. So if you did the video notes for those properties of equality and properties of congruence, this is where it comes into play in our proofs. And right now, most of this proof was algebra, except how we started, which was using the definition of congruent to set up our equation. And that's what we're going to be doing primarily for now. When we get to class, we'll actually be tying congruent and supplementary and complementary and other terms from the flipper together into proofs. I'm going to give an example of one that's complementary angles. So this is what's given. And so that is what I would put all of that for my first line, although sometimes you'll see this as the first line, and these as a line, maybe steps 2 or 3. If you see that in a fill in the blank proof, then if you see something that comes out of nowhere, look to the given, it may have come from there, and you'll write down that it was given. Now, my next line is going to come from this vocabulary word, complementary. What does it mean for two angles to be complementary? It means that their measures, measure of C plus measure of angle D, will add to 90 degrees. And this is also in the flipper. Hey, I told you the angles are complementary. You're going to write an equation that says their measures add to 90, and the reason will be the definition of complementary. So that flipper can come in really handy when you see key vocabulary lines. You'll know that you could possibly use those in your proof. All right, so now we have that, and we have these expressions. So for C, it's 3x. For D, it's 2x plus 30. All I've done was plug it in, so that is substitution. And next I'm going to, for line 4, I'm going to put the like terms together. So I have 5x plus 30 equals 90. So that is combining like terms. In our book, they just say simplify. Next, I'm going to subtract 30 to solve for x. So I now have 5x equals 60, since 90 minus 30 is 60. Since I subtracted, I used the subtraction. If you're going to abbreviate, make sure you put the R so you don't confuse it with substitution. Subtraction property of equality. And not lastly in terms of solving for x, though, I'm going to divide by 5. So I'm going to get x equals 12 using the, well, that was line 5, using the division property of equality. Now there is one more line, because just like a BA, I have to double check what was I supposed to do. I was supposed to show that angle C is 36 degrees. So I do have a 7th line, and I'm not going to fit it on here because I was trying to write a little bigger for you to be able to see. So I'm going to add this 7th line. You might need to add yours somewhere else. Line 7. Well, since I know that x equals 12, and in my given I have that angle C is 3x, I can do 3 times 12, which is 36 degrees, and that's the measure of angle C, equals 3 times 12 equals 36 degrees, and that is substitution, which I do need to write out. We're going to look at a very similar example to this one. This all started from variable expressions in the word complementary, so we were able to set up an equation using the names of the angles, the measures of the angles, and then we could plug in the variable expressions. I'm going to do the same thing with supplementary. If you'd like to, feel free to pause the video and try and see if you can do this line by line if you would like. So for the first thing, we have all of this as our given. This time I don't have to plug it in the end, I just have to find the value of y. My next line comes from this definition right here. These fact that T and V are supplementary. We should all know at this point from our first unit what supplementary means. It means that the two angles, or their measures, will add up to 180 degrees. So that's the equation I write, but I have to do it in terms of the names of the angles, saying the measure of angle T. I can't write the expressions yet. So this is the definition of supplementary. There's our key vocab coming off of the flipper. Now we're going to plug in the 3y for T and the 2y plus 80 for V. And since we plugged those in, the reason will be substitution. The next step is to combine like terms, so I will have 5y plus 80 equals 180. That is by combining like terms. And my last line will, or not my last, second to last line, 5y equals 100, because I subtract 80 from both sides, so we used the subtraction property of equality to get from this equation to this equation, so that's the justification. And my final line for number 6 is that y equals 20. And I got that from this line to this line. I did that by dividing by 5. So this is the division property of equality. Now, sometimes you're not going to be given variable expressions. You're just going to jump into this statement right here and do more with it. If you didn't have variable expressions, we'll have some other vocabulary words that we tie together. But for now, for these types of proofs, you have to set up your equation using a definition, postulate, or theorem. The next is an example of when to use the angle addition postulate. We have this wonderful picture here, and we're given the expressions in the picture. We're supposed to prove that the measure of ABC is 88 degrees. So the first one is our givens, which is that ABD is this expression. I'm not going to write that out right now, but the measure ABD is this expression, and measure DBC is this expression, and the whole thing is 8x. You solved these equations on the Unit 1BA, but now we're going to write a proof with them. So my first line of my proof is going to be about the angles, not the variable expressions. When we were just solving, we just set up our equation and got our answer for x, but now we have to justify why we're setting up that equation. So the measure of ABD plus the measure of DBC should add up to the entire angle, the measure of angle ABC. And my justification for saying that is angle addition postulate. Whenever we have adjacent angles, such as those two, that are adding up to a larger angle, the justification will be the angle addition postulate. So that's the geometry piece. Now we're going to sneak a little bit of algebra into the problem using the variable expressions. So ABD's expression is 3x plus 5. DBC's expression is 6x minus 16. And ABC's expression is 8x. Since all I did was plug in the expressions, my reason is substitution. Now, line 3, we're going to solve the equation. So we're going to combine like terms. This gives me 9x minus 11 equals 8x. So all I did was simplify combined like terms. Next, I'm going to subtract 9x from both sides. I have negative 11 equals negative x. I got that by subtracting 9x from both sides, so I used the subtraction property of equality. Now, I'm supposed to find the measure of angle ABC. I'm not done though, so I'm going to divide by negative 1, giving me 11 equals x. I divided, so I used the division property of equality. The next line that I'm going to put in isn't really necessary, but normally we solve for x, and right now it says 11 equals x. So I'm going to write x equals 11 using the symmetric property of equality. But again, that line isn't necessary because we weren't asked to prove x equals 11. We were just asked to prove the measure of ABC. So I could have skipped that line and jumped straight to this last line, which, since I already had the variable expression, 8x for ABC, I can say the measure of angle ABC equals 8 times 11, which is 88 degrees. And I did that by plugging it in. So the reason would be substitution. Now later in our geometry proofs, we'll focus on where that substitution came from. It actually came from one of our given lines and from line 6. So we would actually say this. We do 1 comma 6 to say that one of our equations came from, actually it would be before that, before line 1 it would have been given information. And the other equation that let us plug stuff in was line 6. But we'll get to that later. So there's some supplemental examples. I'm going to go over just a couple more real quick, 2 more actually. The segment addition postulate, which has this nifty picture. We're supposed to prove this. So we're given all of this. That's kind of like our given. Really, I don't normally put that as my first line when it's segment or angle addition. But you can, so I just put it in there. My next line is going to be about the segments themselves, NM and MO, and NO. So NM plus MO equals NO. I'm saying that this segment piece plus this segment piece, which are connected, adds to the whole thing. That is the segment addition postulate, Euclid's segment addition postulate, that allows us to write that equation. So you'll see that in your flipper. That's the geometry component. Now we're going to plug in the terms. So we're going to do some algebra. So for NM, I have 2x. For MO, I have 3x minus 9. For NO, I have 4x minus 4. What I did was plugged in, so I used substitution. My next step is going to be to combine like terms. So I have 5x minus 9 equals 4x minus 4. I combined like terms. Now, I have 2 more steps to go to solve, unfortunately, before I can plug back in. I need to add 9, or first I'm going to move the variables. So my next step is to subtract 4x from both sides. I have x minus 9 equals negative 4. So this was subtracting, so I used the subtraction property of equality. On the next line of my proof, I'm going to add 9 to both sides. So I get x equals 5 by adding 9. So the 6th line is addition, property of equality. There will be one more line because I wasn't supposed to find the value of x. I needed to get the answer. But what I'm trying to prove is that NO is 20. So I'm going to say NO equals, its expression is 4x minus 4. So 4 times x minus 4. And what I'm plugging in is coming from line 6, and it's that x equals 5. So that's 20 minus 4, which is 16. Well, I think I have the wrong answer for that. So this should have said 16, not 20. There's an error in the problem. So that's the whole expression. That's the answer I get. And so the reason would be that I plugged it in, so it is substitution. And you're going to see that it came from line 1, which had the given expressions for each piece, and from line 6, because I plugged in the value of x from line 6 into the expression that we would see in line 1. And we proved the value of NO. Assuming I solved it right, there might be an error. I apologize if there is. I know the proof is set up correctly. Application of the definition of midpoint. So they're not going to tell you this on any assignments or assessments that you may have. You're just going to be said, hey, this is a midpoint. And you're supposed to know, because of course you've copied down and studied your flipper, or maybe you're just naturally good at proofwriting. Awesome if you are. Most people have to write down and study the flipper. They're going to start with this given information, not the prove part. I didn't mean to circle that. And that's their given. And the next thing they're going to say is, well, wait a second, what can I do? I don't know what I can do. Well, they said the word midpoint. What do I know about midpoint? A midpoint cuts something into 2 equal pieces. Or better yet, my flipper tells me that the 2 pieces are congruent or equal. Now, technically, we're supposed to say that they are congruent. I'm going to draw a picture for this too. EF is what is bisected by the midpoint being D. And so I have that those are equal, and I have ED is 4x plus 6, and I have DF is 7x minus 9. You had problems like this on the last BA, but you just had to find values. Now we're putting it as a proof. So because they say it's the midpoint, here's the steps I should technically say. ED, segment ED, is congruent to segment EF by the definition of midpoint. Now, if you pay attention to my flipper, I actually say that for our purposes, to save time, I will allow you to skip this and jump straight to our next line. ED is equal to DF. Now, if it's by definition of midpoint, or if this was by definition of midpoint that they're congruent, because they're congruent, I'm saying they're equal in measure by definition of congruent. If you see a fill-in-the-blank proof, it'll probably be like this because technically this is the order we're supposed to do it in. You told me midpoint. By the definition of midpoint, I can say this. Hey, I said they're congruent. By the definition of congruent, I can say this. Now for our purposes, when we are writing proofs, not filling in the blank, but writing, I will let you jump straight to this line with this reason. So if you just told me ED and DF are equal, by the definition of midpoint, I would give you credit. Technically, it's not correct. You should have these two lines, but I like to do that. It saves us time when we're writing longer proofs down the road. So now that we have an equation, we can plug in the variable expressions. So our variable expressions are 4x plus 6 for ED and 7x minus 9 for DF. So that is substitution. And now I'm going to solve. I'm going to subtract 4x from both sides. So I have 6 equals 3x minus 9, because I like to keep it positive. And I did that by subtracting, so I used the subtraction property of equality. To get my next line, I'm going to add 9 to both sides. So this is going to give me 15 equals 3x. Since I added to both sides, I used the addition property of equality. Now I'm going to do line 7, which is divide by 3. So 5 equals x, using the division property of equality. Now I was supposed to prove that EF is 52. I hope that's the right number, but it might not be. EF. Oh, so now I got to use the segment addition postulate. That stinks. All right, so I've got to do ED equals 4 by 5 plus 6, which is 26. And there I used substitution from lines 1 and 7. And on that same line, because I'm also going to use the same lines, I'm going to do that DF, I think, yes, DF is 7 by 5 minus 9, which is also 26, still by substitution. You are welcome to write this as a separate line if you want. My last, well, there's technically 2 more lines. I know that EF equals ED plus DF by, you might have guessed it, the pieces add up to the whole. The reason is the segment addition postulate. And then my final line, so we did all the algebra, now we're tying it back to the geometry. I know ED is 26. I know DF is 26. So EF equals 26 plus 26 is 52. And I did that by plugging it in. So it's substitution from lines 8, where I had that they were each equal to 26, and 9, where I had that the 2 added up to EF. So this is technically the formal proof. We didn't quite do it this way when we first did our lessons because we were doing some shortcuts. We were focused mostly on the algebra justifications and setting up the start of the problem. Now, for the most part, I'm still focused on the start of the problem. Can you set up an expression and justify it? Because when we get into mostly geometry, where we're dropping some of the algebra, those are the terms you're going to be using. So again, if you haven't already studied, please make sure that you study this flipper, that you go and record it and study it, so that when you see a line like B is a right angle, you know you can say that its measure is 90 degrees. Or if you see that angles A and B add to 90, you know you can say that they are complementary and give a reason why. Hopefully you found this supplemental video helpful. We will be doing some practice proofs with geometry and a little bit of algebra in class. Have a great day.